Dear students, I am Meenakshi, Assistant Professor from Chikballapur First Grade College. This is the fourth session of Unit 1, that is in the topic of motion. In this session, we will discuss about graphical representation of variation of displacement, velocity and acceleration with respect to time for the body moving inside the fluid medium. Here, in case of an object that is moving at low speed, velocity is represented by v equal to vt into 1 minus e power minus k by m t. Now, this velocity function with respect to time, since it is exponential function, graph can be plotted as shown in the figure. Time is taken along x-axis and velocity is taken along y-axis. Here, the maximum limit of velocity can be taken as terminal velocity. So, if you plot the graph shows exponential variation. That is, at time t equal to 0. At time t equal to 0, here v also equal to 0. As t increases, v also increases, and at an infinite time it attains terminal velocity. And here we have observed in the diagram one more factor, that is 0.63 times of Vt. That I have already explained in the last session. That is, at an instant of time t is equal to m by k seconds, velocity attained by the particle or an object is given by 63% of terminal velocity. All the calculations already done in the last session. Here only graphical representation is indicated like this. That is, velocity of an object increases exponentially. Exponentially means it is a slow variation. Next, we will go to acceleration of an object. So, we know that acceleration is nothing but the rate of change of velocity. Okay. It is already derived a equal to g into e power minus k by m t. So, graphical variation is represented as shown in the diagram. At time t equal to 0, a equal to g. At time t equal to 0, a equal to g. That is, it is starting with this acceleration due to gravity. The body is starting at acceleration due to gravity. As time proceeds, acceleration of the body goes on decreases. At an infinite time, it reaches 0. So, observe the diagram's velocity and acceleration. So, here they are exactly reverse. At time t equal to 0, we can take v is nothing but 0. As time increases, v also increases. But in case of acceleration, at time t equal to 0, a is equal to g. That is maximum. A equal to maximum. That is g. As time proceeds, a reduces because in exponential term it is having minus value. It reduces and finally it reaches 0. As t tends to infinity, e power minus infinity is 0, then a equal to 0. That is, at an infinite time, acceleration of the object reduces to 0. So, here just I will made the calculations for displacement of an object inside the medium. So, we have learned that v equal to dy by dt. So, dy can be written as v dt. Now, substitute the value of v and write the expression for dy. So, on integration and simplification, you will get the expression for y. That is displacement of an object. So, this is simple mathematics of integration. So, here displacement, it varies with respect to time as shown in the diagram. Y represents displacement. Okay, it varies linearly. The straight line graph indicates linear variation with respect to time. Now, here Final concept of this unit 1 is concept of terminal velocity. Already I told in the last classes, terminal velocity means when an object is moving in some resistive medium. So what is the opposing force exerted by the medium, that is viscous force, when it is exactly balanced with the weight of the object, then the total force acting on the object can be taken as 0. That is, both the forces get balanced and the object attains some constant velocity, that is called as terminal velocity. Terminal velocity means it is the constant velocity attained by an object when it is moving inside the fluid medium, at which both weight of an object and the resistive force